All right. Good day, everyone. Welcome to the first workshop in a list of Argent's bi-weekly workshop, bi-monthly workshop rather. So today we're going to be looking at mastering the new Cairo syntax, basically by coding. So it would be cool if you came with your laptop to probably code along. Well, I think that was few months ago, right? Or yeah, a few weeks ago. Basically, we released the main Stacknet repo, which contained like minimal implementations of different protocols and concepts, like in Cairo one. But that has already been out of date. So we're just going to in today's session, basically, we're going to work on building some probably implementing some of those protocols, right? In like the new Cairo syntax. And because of time, we're just going to just dive into the document. So just in case you are not familiar or you've not read about the new contract yet, I'm just going to drop a link to the community forum post, right? That should help you get up to date. Okay. Yeah, a minute. Yeah, and just because of connectivity issues, right? I'm just going to turn off my camera. So let's just focus on the code editor. Yeah, all right. So probably if you are live with me, right? Could you probably just CGM in the chat? Right, not getting any responses yet. Okay, so but because of time, let's just move forward. Let's move forward. All right. I already have my Scarb set up, right? So basically for the workshop today, we're going to be using Scarb. And if you don't have Scab installed, you could just head over to the documentation to check out the newest release, right? And I already have Scab set up, right? So just going to make a few changes and get started. Okay, right. Let me just clear this. So we are going to start with just going to follow the same format we have. Let's make this a new folder. It's okay. That's following the format we already have in the main Stacknet repo. Um, okay. Yep, and just to make sure we can build this file, just going to add this here. Here. Try to just rename this to ENS instead. Okay. All right, so just going to come here and reference the ENS file. And in the lib.cairo, right, we're just going to go ahead to add this. So we'll be able to build this later. All right. So basically the new syntax is not like very much different from like the old syntax, right? There are just minimal changes made to mostly the outermost part of the contract. For example, if you probably wrote the old Cairo, right, you know that while we had the view and the external attributes, right, that was not exactly in feet of the contract, but those the contract type is now enforced, right? So the view function can no longer mutate the state of the contract, except it's like for the state to be mutated, right? You'd have to use like an external contract. So we're just going to get started with declaring this as Stacknet contract, right? Using the Stacknet contract attributes, and we're going to specify a module. let's call this ENS. And we're going to be importing some stuff we're going to be using, right? So we want to import from Stacknet. We probably want to import like the get caller address, and is there any other thing we'll probably want to use? I don't think so at the moment. So we're just going to leave. Okay, yeah, we're going to need the contract address data type. Yeah, basically, if you don't understand what I just did, right? So normally to let's say import e module, right? You probably want to do something like this. But basically, what I'm just doing here, right, is I'm trying to import multiple methods, right, from the Stacknet module. So basically, I grouped them into using this, right. So with this syntax, I could probably import as much things I want from like the Stacknet library, right. So I'm just going to clear this, and we're going to go forward to specify our storage variables. So with the old contract rights, you'd probably have known that if you wanted to specify a storage variable with the old contract, we'll just probably do that using a struct, right? There was no need for like the storage attribute. We'll just do this, right? And put our storage variables in here. But with the new syntax, you'd need to specify the storage attributes. So we're just going to put in here the names, which is we want to store like a mapping of contract address to like it felt 252, right? So I think I should have started with explaining what we are building, right? So mentioned earlier that we released the Mean Stacknet repo that was a few weeks ago, right? Which contained like minimal implementations of different standards and concepts in Cairo. So like I said earlier, the previous code was with the old Cairo one, and we are just trying to update that to like the new syntax by basically writing it out in the new syntax, right, while learning along. So we're going to start with the first contract in the repo, which is a simple ENS contract. So if you're familiar, ENS stands for Ethereum Name Service, right? So basically, we're just trying to implement a simple namespace service in Cairo. So it's going to contain like a single external function, which is the store name function, and a single view function, which is the get name function. And we're going to have like a storage variable names, which is going to be a mapping of the address to the name, and which is basically going to be used to assign names to every address. Finally, we're going to like emit a simple event, right? Stored name, which should be emitted each time a name is stored. All right. So basically, we already created our mappings. That's our names mapping, right? Which stores maps a contract address to a name, right? And just if probably if you're not familiar with how things are in Cairo, there are no strings in Cairo. So basically, we would want to store a name using like it felt 252. So next up we want to specify our event that will be emitted, right? So we can do that using the event decorator. Now there's a bit of change as to how event is implemented, right? This time around, if you to sorry for that, this must be an event. So we want to basically specify all events inside the event enum, and we want to emit an event called stored name, right? Stored name, and we're going to be creating this struct called stored name. We have to derive some things. Yeah. Just derive drop and stacknet event, right? So we need to specify the struct stored name. But we need to also derive drop show, okay, the stacknet event. Right. Then over here we're going to specify a struct called stored name, which we want to emit each time a name is stored, right? And the stored name is basically going to have the address, going to hold the address, which is going to be a type of contract address. And it's going to hold the name, which was just being stored, which is going to be a type of L252. All right. And next up, we want to we're going to specify a constructor. So if you check the repo, that's the mean stacknet repo, you see that this is not exactly compulsory, right? It doesn't even make sense in the context of this contract. But basically, the idea was to teach you how to specify a constructor in your contract, since that was like the first contract that was being implemented in the repo, right? So now the constructor is going to take a reference self to contract state, and we want it to take an address. Take an address which is going to be of type contract address, and we want it to take a name which is going to be of type felt 252. All right. Now, I think here is where things begin to get funny, right? You'll probably be asking what is this first variable we supplied. So basically, with the new syntax, if you check the docs, I'll probably send it later. That's a community forum post by Feed the Fed, right? You would see that when you want to specify like passing for each function, right? Constructors, external functions, view functions, you need to pass in the state of the storage, right? The storage into the function in order to have access to the storage, basically. So for a function, right, or a method which basically modifies the states, if the how you know if a function is like an external function, right, is we're going to pass a reference to it. Basically, if you check the Cairo book, right, the difference between references and snapshots, you would notice that a reference can actually be modified, but a snapshot cannot, right? So basically, if the contract state is passed in as a reference, you should know that that function is going to modify the state of the storage. But if it is passed in as a snapshot, so let's say we have a view function basically, which is going to be the get name, right? And we pass this in as like snapshots, basically. We pass the contract state or storage basically in as a snapshot. You know that this is going to be a view function. So basically, we're just passing a snapshot of the storage to the function, which means that this function does not have the ability to mutate the state of the contract. So with this now, we no longer have the need for explicitly declaring external or view functions. So basically, by looking at the function body, you should be able to tell whether the function is like an external function or if it's a view function. So just to reiterate, right, if it's an external function, we're going to pass in a reference so that we can be able to mutate the state, right? But if it's a get function, if it's a view function, right, we're going to just pass in a snapshot. Now, after passing, if you pass in a snapshot, right, and you try to mutate the state, the compiler will definitely throw errors, right? All right. So going back to the constructor, basically we just want to we're just going to make a write. Okay, we're going to call the write method on the names, right, on the names storage variable, right, and it takes in a contract address and the field 252. So we're going to pass in the address. Sorry, it's passing the address, and we're going to pass in the name that is being stored. This is basically what we're going to do in the constructor. So basically, if you're new to smart contract development, a constructor is basically how you initialize the contract variable, right, on deployment. So basically, each time we deploy the contract, we're going to need to pass in an address and the name, and that address and the name will be initialized within the name storage variable, right, on deployment. Right. So we're just going to leave the constructor function like that, right? And we are going to go into the next thing. So over here, we're going to specify this. I will explain all this later. And we're just going to call the generate trait because we don't want to manually specify the interface. And right, so we're going to call say implementation of let's call this ENS implementation of ENS trait. All right. Now, what exactly is going on here, right? So, with the new contract syntax, right, it is compulsory to declare an implementation, like to your contracts functions basically should be contained within an implementation that connotes to a particular trait, right? It needs to, for example, if we had our interface specified manually, right? And our implementation basically is supposed to like um be like connotes, right? It's supposed to like align with our interface, right? Unless our compiler will throw an error. So every single function, your external and your view functions, apart from the helper functions, probably which is not supposed to be part of the interface, you would want to specify them within an implementation of the traits that would probably traits basically the interface of this particular contract. And that also helps because if, for example, someone else wants to, let's say, use your make calls to your contracts, right? He doesn't need to go ahead to probably start specifying another interface because you already have an interface that your contract aligns with, right? So in here we want to specify the store name function. Let's just find the store name function. Okay, something I didn't mention also, the generate trait. What the generate trait basically does is it helps us generate the trait automatically. So if you add the generate trait attribute, right, the compiler would generate an interface that is aligned with your contracts, basically the functions contained in the implementation. But if you probably do not want to use the generate trait, right, you probably have to like come over here and specify your interface manually. Probably want to do something like stacknet interface, right? And over here, interface, right? And then you want to specify your interface ENS, right? Let's call this IENS, and this is going to take in the contract states basically. And you just want to specify your interface. That's the get name and the store name function in here. So if you had the interface specified manually already, you probably do not have a need for the generate trait. You could simply do something like implement ENS implementation of ENS traits. They were just going to come here, right, and just pass in the contract state. And basically with this, just that you should know that whatever you specify here needs to align with your specified interface unless your compiler will throw an error. So, but for the purpose of this particular contract, we're not just going to go ahead. So I'll probably do that in the RS20 contract. So I'm just going to remove all this and I'm going to come back here and add the generate trait. Right. So inside the store name function, right, like I said earlier, the store name function is going to be an external function. It's going to be mutating the state of the contract. So basically we want to pass in a reference to the contract state. And what else we want to pass in, right? So we want to pass in the name we want to store, right? And I think that would be about it. And for the get name function, we could just specify the body noun, right? The get name function. This is going to be a view function. So basically, we want to pass in snapshots to the contract state, right? Snapshot to the contract state, and probably need to pass in the address we want to get the name for. And this is going to return if you're 252, and we'll just leave this like this. All right. Now within the store name function, we the first thing we'll probably want to do, right, is want to get the person calling this function to use the get caller address to get the caller. And probably the next thing we want to do is to call the right method on name storage variable, and we're basically just going to write the okay, so in case this syntax seems strange because coming from the old contractor, I will probably have done this like this instead. I probably have done something like this, right? So the so probably have done something like this. But with new syntax, right, you notice that we call to self. Self is basically the contract state, right? And the contract state basically is our storage variables contains the name storage variables. Then next up, we want to emit our event, right? And to emit our event, basically we can just do self.emit. And our events, the event we want to emit is the stored name event, right? So we're just going to simply specify the stored name, right? And the stored name structure is going to take in it takes in what? It takes in the address on the name. So the address is going to be the caller. So just can say the address should be like the caller. And what else? The name is just going to be the school name. All right. And that's how basically you emit events with the new syntax, right? Which I believe is safer and way more cleaner. And all right, let me see if there are any questions just before we proceed. Right, there are two questions in the chat. Someone is asking which version of Scab and Cairo do you have installed? Right, so the version of Scab I have installed, right, is I think is 5.0.2. Let me try to join the chat. Okay, can't. Yeah, the version of Scab and Cairo I have is basically the 5.2, 5.0.2 rather. Okay, so the get name within the get name function, right? We want to get the name for this particular address, right? So we're just simply going to make a read call to the name storage variable, right? And we're going to pass in the address. And so, just like same with Chiron, right? You can either decide to do something like let name be equal to this and return name, which I feel like is a longer process, or something cleaner and neater you could probably do is just emit the semicolon at the ending, and the compiler would know to like return the particular name, to know to return the name which you just read, right? And I think that would be about it for the ENS contract. Now, if you go over to our terminal, right? I don't know if I can increase the font of this. Minute. Let me try to increase the font. I just saw that. Hmm. Right. So I think this should be more visible. So we're just going to come here, and I think we've got this, got our part specified correctly. So we're just going to come here, and sorry, we're going to run scar build. Okay, we have an error. It says legacy map type not found. What did it do wrong? Names legacy map mod ENS. Okay. Right. Minutes. Stagnate contract mod ENS. Supposed to be storage variable, right? Compiling. Oh, right. I think we are missing something here from dependencies. So I'm just going to go to scarp docs and the contract targets. Okay. Yep. This. All right. I'm just going to come here and specify this here. Just clear this out. Basically, this is what's enables Carb to like contract compile stacknet contracts, right? So I'm just going to clear this once again. Sorry. And I'm going to come here, clear this, and run scar build. And so now our contracts build built correctly, right? So you could always find the Sierra for your build contract in here. You could always find that in here, right? And yeah. So next up, we are going to move over to implementing the ERC20 contract. But before that, let me check if there are any questions in the chat. Hmm. Okay, someone is asking, what does the derive do? Right? I get that. Okay, yeah. So what does the derive do? Okay, so basically what the derive does is like it enables you to generate some certain traits for some for example, you could generate using the derive, you could generate some certain traits for data types like structs, I think for enums too, and a few others. So for example, in the derive here, the derive which you can see in here, right? We are deriving the drop trait to ensure that every time we are done with this particular event, right, it is dropped out and it doesn't cause issues. Then we are also deriving the stacknet event, basically, which is which it's more like it derives the event traits for this particular enum and for this particular storage. Just like a way of telling the compiler, okay, this is not just a normal structure, right? But this is like an event that can be emitted. I don't know if that answers the question. Okay, John Williams is asking, are you using the latest Cairo version? Yes, I am using the latest Cairo version that comes with them. I think Cairo compiler 2.0. Okay, someone's asking, please, what's the dependency you added to the scarb.toml? So basically, if you check the scarb docs, right, it's more like how you inform scarb that you are going to be writing, like there's a stacknet contract involved, contained within your project, right, which you want to compile. So without that dependency, which you just added, that's if you check the scarb.toml, right, without this dependency, right, it will be impossible to compile.
And looks like we have lost Darlington. So this is Antoine from Argent, and let's just give him a few minutes to come back. So anyone in the crowd going to Starknet CC next week? Argent will be there as well. Hey, John, I just see your message. No, indeed, we have a technical issue here. Darlington is fighting his way back.
All right, can everyone hear me now?
Yes, we can, Darlington.
Yes, sorry about that. Having
Welcome back.
some
Welcome back.
issues with my
Ah,
network.
no worries. I see in the comments that other people's visas got refused for next week, so seems like it's a common issue.
All right, can you guys see my screen?
Not yet. Yes, it's coming. Yeah, that's it. You're back on stage.
Right. I really apologize for that. I think I'm having like some serious network issues. All right, so I guess you guys lost me when I was trying to explain like while you should add this. So I think that was Jim Wax the question, right? That was okay, Evans Okoli, right, asked while I added that dependency. So like I was explaining earlier, you could see that without the dependency we had issues like compiling our contracts because Scab was not able to recognize we had the startnet contract within our project, right? So you could see we had issues with specific features which are like specific to contracts like the legacy map, the contract state, and so on. So basically, adding this dependency enables you like in very simple terms, enable you like compile stagnant contracts with Scab. I don't know if that answers your question. Right. So just because I don't know where you guys lost me out, so I'm just going to do a quick recap through what we did with the ENS contract. So basically, the ENS contract, like I said earlier, is like a simple Ethereum name service which basically maps an address to a name, and you could always query the name to get the address, like query the address to get the name. So both of them are tied just this the way like an ENS works. This is just like a very simple implementation, right? So basically, we started with creating the storage variable, like specifying the name storage variable, which is like using legacy map is how we create mappings, right? We created a mapping of contract address to like the name, which is a FL 252. And as I explained earlier, probably with the old Cairo, right, you probably have not had any need for this for the storage attributes, but with the new Cairo, as you can see, when we comment the storage attributes, right, the contract is unable. As you can see, storage structure must be annotated with storage. The contract is unable to detect that this is like a storage variable. So we have to add the storage attribute to our storage structure, right? Then we went ahead to create our events. So you start with declaring the event attributes. Then you want to derive some certain traits, such as the drop and the stagnant event on this event enum, right? So the event enum basically contains all the events you're going to be emitting. So every single event you want to emit in your contract should be specified within this event enum. Now, as you can see here, the event enum basically most of the elements contained within the event enum, right, are structs. So you have to specify the struct for this event you are listing. For example, we had the stored name event, right? Then we came down here to specify the stored name struct, which is going to be emitted. So basically, within the stored name struct, you want to specify every single variable or whatever it is you want to emit. So for us, for the ENS, right, each time a name is stored, right, you want to emit the address that just store the new name and the name that the address choose, right? The name that was being tied to the address. And the same way we want to derive the drop and the stacknet event on it, right? Then we had the simple constructor. So the constructor within itself, like I said earlier, is not like very doesn't exactly make sense in this use case, but the repo, the idea of adding it right was to basically give us an idea of how you could specify constructors within Cairo, right? And we said that the constructors, if you're not use smart contracts, right, can be used for initializing storage variables on deployment. So each time we want to deploy these contracts, right, so we want to specify the constructor within the event enum. So we have the constructor, right, and we have the event enum. name, which is going to all right. Then we came down ahead to do some stuff. So we started specifying the external v0 attributes, which because if you check the community forum post, right, by Feed the Fed, you notice that the contract syntax is not still stabilized yet. It's going to come in two stages, right? The first stage is this particular one where different things were changed, like for example, the enforcement of view and external functions, and a little other updates that was made to like how you could write contracts. This I think the second stage, which is most likely going to be the V1, right, is going to be focused on extensibility. So it's the by the time that update is out, right, to be able to like use components to basically extend smart contracts. So we now had to add the generate trait, which I said like generates a trait that aligns with our implementation here, right? So this comes in handy if you don't want to go ahead to like specify the trait for your contract implementation manually. So we just use generate attributes rather to like specify the traits. Then we had the implementation. So basically, the implementation contains the implementation for our trait or our contract interface. And like I said earlier, the implementation has to align with the interface which you declared earlier, or else you're going to like run into errors with the compiler. That's if you are going to be writing out or declaring your interface manually. So within here, since we are using the generate trait, we can add as much functions as we do here, and the compiler would like generate an aligning interface. So we went ahead to specify the store name function. So basically, as you can see, we no longer have to do stuff like come here to add the external attributes, right? Like you would normally do it the previous Cairo one. And like I said earlier, this is much better and cleaner as and also safer as with the old version of Cairo one, right? You could basically specify a view function that mutates the state of the contract. Meanwhile, we know that view functions are not supposed to like mutate contract states, but like with this new syntax, right, these external and view functions are like enforced. So basically, an external function can mutate the state of a contract, but a view function cannot. And the way that is done basically is by passing, for example, for an external contract, we're going to be passing the reference of the contract state to the external contracts. And like I said earlier, if you check the Cairo book, right, you'd know that one major difference between references and snapshots is the fact that references can be mutated, but snapshots cannot. So basically, this is how you enforce external and view functions. So once a reference is passed to a contract, we just by looking at the function body, we can know that this is an external function, right? At it has the capability to mutate the state of the contract. While looking at this, right, this passes in a snapshot. So we can conclude or deduce that this is a view function, because if you try to mutate, let's say you tried right here, right, you try to mutate the state of the storage variable as the state of the contract, you're going to get an error with the compiler. The compiler is going to throw an error. So basically, what we did here was very simple. We started with getting the caller address, then went ahead to like write the caller and the name right to the name storage variable. Then went ahead to finally emit the struct we defined earlier. So the stored name struct. So basically, to emit, you just use self.emit, and you specify the struct you want to emit, and within the struct you're going to specify all the variables you want to emit in the events, right, like the address and the name. So basically that is all basically for our ENS contract. So like I said, if you have any questions, you could just drop them in the chat, and I'll do my best to attend to them. All right, so because of time, we're just going to be moving into the next user folder. Always make okay new folder. So I'm just going to come here and right. And inside here we want to specify our ERC20.Cairo file. Okay, and that'll be for it. Then in here, we want to create a new file, which we're going to just call 20 Cairo. In here, we're just going to okay. And then finally, that will leave your Cairo. You could just come in here. It's right. So basically, we are not new to the ERC20 standard, right? So what we're going to be doing in this section, right, is to implement the ERC20 standard from scratch. So we're not going to be using any libraries, no OpenZeppelin library. We're just going to try to build this up from scratch. But because of time, what we're going to do is we're going to just we're going to get the interface. We're going to try to get the interface from okay. Oh, right. Because of time. So the interface basically specifies all functions would need to be implementing our contract. So basically our contract implementation has to contain all these functions in here in order not to throw errors. Okay, we need something here. So I'm just going to come here and going to import the contract address data type. What's the reason for the errors? Okay, so basically, like I explained earlier, creating an interface, right, can simply be done. First of all, we need to do that. First of all, we need to specify the interface attribute. Just before I move on, be sure I lost me. Oh, okay. Yes. Can you guys hear me now? I just want to confirm because I'm not lost me again. Oh, all right. So, like I said earlier, we are going to start with specifying the interface attributes, which, as you can see here, you do that by using the hash symbol stacknet interface. Then we specify an interface basically in Cairo using a trait. So the trait is more like specifies the attribute of this contract. So these are the functions we want to implement in our contract. And as you can see, interfaces are basically just basically contains the function body, that's the name, the parameters, and the return arguments, but you can't specify a function body with interfaces, right? So we are going to be implementing the get name function, the get symbol function, the get decimals function, the get total supply, and a whole lot of others. So I don't think we have to go through this explaining what each of these functions does individually because I assume a lot of us are already familiar with the RS20 contract standard. But probably while we build right, we'll try to touch on that too. So basically, we are going to start out as always by letting the compiler know that okay, this is like staffnet contracts, right, and not just Cairo program. Okay, and we want to specify a module for our contract. Let's call this ERC20. Right now, there are certain things with certain imports, certain methods we want to import from the core library for use. Right, we would most likely want to use I'm just use this. So probably want to use the get caller address. Would also likely use the contract address type. I can't think of any other thing for now. Then I'm sure we're going to use the zeroable. We have to use this, right? Any other thing we'll probably use, right? Would implement it, would import it as we go forward. So we, as always, we need to specify our storage struct, our storage variables. We're going to do that using the storage struct, right? We're going to see storage, right? And in here, for our 20 token, we want our 20 token to have a name. It's going to be of type field 252, right? We want our ERS20 token to have a symbol, which is going to be of type field 252. We also want it to we want to also specify our number of decimals, which is going to be a U8. Then we are going to specify we're going to need the total supply of our token, which is going to be your 256. The other thing we probably need, yeah, we'll need the mapping of balances. We'll need to be able to track the balances of users, of own people who own this S20 token we're about to create, right? So we're going to, it's going to be a mapping of contract address to you in 256, right? That's the address of the owner to the amount of token that this owner owns. Finally, we want to track the allowances. And within the allowances, which is also going to be a mapping, right? We want to map a tuple of contract address to let's say you're in 256. So basically what we did here, right, is we're mapping a tuple to you in 256. This tuple is basically the owner and the spender. So if you know about the allowance function, right, it enables you to like give someone the right to like transfer your tokens out of your wallet. So you want to, let's say, approve a certain amount for a particular person to probably be able to call the transfer from function. We are going to need to specify the owner and the spender in order to get the amount that is allowed. So basically, this stands for the owner, this for the spender, and this for the amount of token that will be approved to this particular person. So after that, we would probably just we're going to have events, of course. So we're going to specify the events, and in here, the first event. Okay, we're going to do that in an enum, just like we did in the previous. Let me be sure. Right. Okay, so within the enum, the event enum, rights, we want to call the transfer. We want to be able to emit a transfer event. That's each time a transfer goes on, right? We want to emit an event, and each time an approval goes on, right? We also want to emit an event. We're going to do the transfer and the approval, right? Then, like I said earlier, these are structs, but these structs are not they've not been specified yet. That's why you can see an error that says type not found. So, but before, okay, we need to derive that. So before I forget, I want to make sure that events are dropped and implement the event trait, right? So in here too, we'll just, we also want this to implement the event trait, all right? Then over here we want to specify a struct, right? And this transfer struct is basically what are the things you think we want to emit each time a transfer goes on, right? We want the outside world to be able to know the address the transfer originated from. So this is going to be contract address. We want to know the recipient, the person the transfer is going to, right, which is also going to be the contract address. I want to know the amount. Let's call this value. This is going to be UN 256. All right, then next up, we want to do same for the approval, and we're going to still going to derive drop, and then the startnet event, and we want to specify the structure, right, which we're going to call approval. And the struct is going to, what are the things you think we want to emit each time an approval is carried out? We probably want to let the outside world know the owner is going to be of a type of contract address. Then we want to also emit the spender, which is also going to be a type of contract address. And finally, want to emit the value which has been allowed or approved. And this is going to be like a UN 256. All right. After doing this, right, next thing we'll probably want to do is specify our constructor. Okay, so we're going to, as always, our constructor needs to be called constructor, right? And since it's definitely going to mutate states, we want to pass in a reference to the contract state. and we want to pass in the name. Okay, let's just make the syntax cleaner, right? Let's just do this. Let's do this. Let's do this. Two. The symbol is going to be a felt 252. The what else again? The decimal is going to be like a unit 8. And we want to pass in like an initial. Let's call this an initial supply. Let's just add this here. Add this here. Let's call this initial supply. And this is going to be like a unit 256. And well, what else again would we need? Yeah, the recipient, the person who's going to be receiving the amount you're going to be initializing, and it is going to be of type contract address. I think that would be it. Then in here, you want to call the right method on the name storage variable, right? And we're just going to write name. And we want to call the right method on the symbol rather than name symbol, and we're just going to write the symbol in here. And for the decimals, we also want to write the decimals, right? Then we will, for to the total supply, we would be writing the initial supply we have. Okay. And I think that would be it. How many storage variables do we have here? One, two, three, four. Okay, the balances or the allowances, we also want to initialize that. So we want to update the balance for the recipient. Okay, and for the recipient, basically we want to the recipient is okay. The recipient and the amount we are going to be initializing is the initial supply. Okay, right. So, but something I would want us to do, right, is let's just put in a check here and to ensure that the recipient is not a zero address. Let's our token go into oblivion, right? So we're just going to use the recipient as is zero. And if the recipient, we want to assert that the recipient is not zero, rather. So using this, we can just simply negate everything. And if the ones outside the recipient is not zero, if it is, we're going to just say transfer to zero address. I think that works. Transfer to zero address. Right. Then after doing all this, the next thing we'll probably want to do, right, is let's just emit an event, the transfer event, right? Because basically transfer just happened here. So we're going to come here and I'm going to emit the transfer. We're going to emit the transfer event. Okay. Now the transfer event is going to it needs the first thing it needs, right, is the from, the to, and the value. So the from is a zero address. So we are probably going to need it's called we're going to need to import something. Within here, we're going to I think it's called Stacknet address constant. Is that correct? Nope. Or contract address constant rather. Yeah, I think that's correct. So we're going to use this to specify initialize a constant address, right? So we're just going to just say the constant from is going to be a zero address. So we're just going to by making mistakes. Contract address constant, and in here we can just pass in zero. Right. Then our two is going to be the recipient, basically. And the amount, the value rather, is going to be the amount we are sending. Oh, sorry. the value is going to be, sorry, the initial supply. No, there's no amount here. Initial supply. Yep. I think everything works now. So yeah, so we just emitted the transfer event and basically passed in the from argument, which is the contract address concerns as a zero address. Basically, we just initialize the zero address. The two is going to be a recipient, and the value is going to be initial supply. So before I move on, let me just confirm there are no questions. Okay, there are no questions. All right, let's just continue. Okay, so the next thing we want to do right after the constructor is to specify our implementation. So what we want to implement now is this trait. So we're going to ensure that our contracts, like it conforms. Finally, I found the word I was looking for. It conforms to the streets. Yeah. So we are going to come here, and as always, we need to specify that this contract is going to be, this is a version 0 contract. Then we're not going to be using the generate trait. So we're simply going to just specify our implementation. So let's call this ERC20 implementation of ERC20. We called our trait what? IRS20. All right. All right. So let's do this, call this IRS20 implementation of IRS20, and we're just simply going to pass in the contract state. Pass in the contract state. Right. Okay, so this is currently not found, so we'll need to import it. So we could just come here and just simply say use super IRS20. And we still have errors. Implement IRS20. Not all traits items are implemented. Yeah. So like I said earlier, we're always going to run into errors if you don't implement all the traits that are contained in all the functions rather that are contained in the interface. So our implementation has to like conform to this particular interface we have here. Right. So we're just going to start with the first. Just I need to have access to this, right? So I'm just going to, let's try this. Let me split this, right? Yep. Okay, and so I'm just going to look at that, and we're just going to implement this together. Let me reduce this, right? Just for more screen state. All right, so the first function we want to implement here, right, is the get name function. And as you can see here, it takes a snapshot because it's a view function and it returns a field 252. So we're going to come in here and we're going to call the get name function. And like I said earlier, it takes in a snapshot considering it's a view function. Right, and it returns a field 252. To field 252. So basically what we want to do here is just simply return the name we've stored. We stored in name. Remember, we initialized the name during deployment using our constructor. So as you can see here, we have the name storage variable. So we're just simply going to get the name that is stored within the name storage variable. So we're going to see self.name.read, right? Read. Yep. And like I said earlier, once you emit the column, the semicolon from here, right, the compiler would automatically return whatever it is that that's the name that is gotten here, right? And the next thing we want to specify is the get symbol function. And that too is going to take like snapshot of the contract states and return a field 252. And in here we want to return self.symbol or read. Right. Then the next thing is to get the decimals, right? Want to get the decimals. And that is also still going to be snapshots. Okay, and we want to get return unit 8 instead. And we're just simply going to say self.decimals.read. Okay, let me just confirm there are no questions before I proceed. All right, no question. So guys, if you have any question, just don't fail to drop it in the chat. So let's go ahead to implement it to our supply. That too is going to like take a snapshot, and we want to return a main 256, and we're just simply going to say self the total supply read, that we call that total supply. Yeah, we did. Okay, then we want, next up is the balance of function, right? So that's still a view function, so it's still going to pass in snapshot of the contract state. And for this, we want to return the balance, which is going to be in 256, right? And what we're going to simply do here is we want to first of all get the person calling this function using the get call address. Once we get the person, the next thing we want to do, right, is we want to call the read method on the balances, and we're going to pass in the caller. So I'm getting an error. What is that? Number of parameters implementation is incompatible. Oh, sorry. But the balances, we need to pass in the accounts rather, not get this manually. Sorry about that. Okay. The account is going to be contract address. All right. Then in here, we want to pass in the account. Next up, we are going to be implementing the allowance. On the allowance is still a view function, so it's going to take in a snapshot. Right, and we want to pass in two stuffs. The owner is also going to be a contract address, and the spender, which is going to be contract address too. And we want to get the allowance. The allowance is going to basically be in 256. Right. In here, we are just simply going to do self those allowances. I think that's what it's called, right? Self dot let's check our storage allowances. Yeah, self dot allowances, and we're just simply going to read here, and this is a tuple, right? We need to pass it in as a tuple. We're going to pass in the owner and the spender. And since there is no column, this is going to be returned automatically. Now we move into our external functions, that basically functions that mutate the state. And the first is we're going to be implementing is the transfer function. So this transfer function basically is going to take a reference to self. That's a reference to the contract state, right? And we want to pass in the recipient, the person receiving the money. It's supposed to be a contract address. And the last thing is the amount, which is going to be in 256. And we're going to do something here. First of all, we're going to get the person calling this function. That's supposed to be the owner. We're going to use the get call address method to get that. And next up, we are going, rather than implement the transfer logic in here to make things cleaner, we're going to dedicate that to the helper function, which is basically an internal function. Let's just call this transfer helper. And we're going to pass in three things: the owner, the recipient, that's the firm address, basically, the recipient, that's the to address, and we want to pass in the amount. So the things that we'll need for. So as you can see here, we are getting an error because this transfer helper function is not implemented yet. So what we're going to do is, since it is not part of the contract body, right? It is not part of the contract interface. As you can see here, we don't have any helper functions contained in here. They are basically internal functions. We are going to be creating a new separate implementation for that, right? I'm just going to, this implementation function is just going to just going to give it the generate traits, and we are going to basically we are passing in the generate traits attributes because we have no interest in specifying the interface for this particular implementation. So we're just letting the compiler know you could just generate this automatically yourself. So we're just going to call this let's call this ERS 20 implementation just for the all standard. Okay. The next up we of ERC 20 let's call this helper traits. And like I said earlier, because of the generate traits, the compiler would do the work of generating the interface automatically. All right. So the first function we want to contain in here. So this implementation basically is going to contain some helper functions for our smart contract, right? And these helper functions, remember, they're internal functions, so like nobody needs to have access to it, right? So we are going to start with implementing the transfer helper. The transfer helper is going to be it's going to mutate state, so we're going to just pass a reference to the contract state. Okay. The reference to the contract states and other things that are needed, as you can see here, is the caller, the recipient, and the amount. So we're going to basically we need the caller basically for us. We expect it to be the sender, right? So yeah, let's just call this owner instead. And it's this is going to be a contract address. Let's call this the recipient. The two address, let's just call it the recipient. It's going to be contract address too. And the amount, which is going to be you in 256. Right. Now, this transfer helper function, basically, as you can see here, we have every single thing we need, right? The caller, the recipient, and the amount. But we want to do some certain checks, right? First of all, let's confirm that the caller, that's the owner rather, is not a zero address. It's not a zero address. Right. So if it is, we'll just want to say um from a zero address. The transfer is coming from a zero address. But owner is a zero address. I think that's more detailed. Owner is a zero address. And we want to check also that the recipient is not a zero address. Recipient is not a zero address, right? And if it is, we want to see recipient is a zero address. Right, that's cool. Then having checked all those, we can now go ahead to carry out the transfer. So the transfer basically is just changing of balances. Now for in order to prevent reentrancy attacks, right, we want to ensure that we deduct the balance of the owner first. And to do that, we are just simply going to make a call to like the balances storage variable. This time around we're writing, and we want to write the address of the owner. For the owner, right, we want to ensure that the balance is deducted of the current amount. But to do that, we will need to get the current balance first. We can simply do that by doing something by making a call to the balances, right? A read call to the balances, and we want to pass in the owner basically. Now that is going to call the balances function, make a read call to the balances function to get the current balance of the owner. Now the new amount we would be basically the current balance of the owner, right? Minus the amount that the owner wants to send out. Right. So this is basically how we can deduct the balance of the owner. Now, having deducted the balance of the owner, the next thing we want to go ahead to do, right, is increase the balance of the recipient. And we are simply going to do self the balances dot right, and we want to pass in the recipients. And first of all, we want to get his current balances, his current balance, right? The current balance of the recipient, and we want to add the new amount to it. I believe this is enough for like changing the balances, right? So just to explain once again, when the transfer function is called, it delegates the logic basically to a transfer helper function. Now, this transfer helper function within it, as you can see here, after checking that the owner and the recipient are no zero addresses, right? We now come here to basically update the balance of the owner first. Like I said earlier, I would just update the balance of the owner to prevent reentrancy. So we'll start with updating the balance of the owner. As you can see, we make a call to check the current balance. And when we do, we basically just subtract the amount from the current balance, and that will form like the new balance of the owner. Then we do same for the recipient. So basically, for the recipient, we make a call to check his current balance. Then we add the new amount. Now, having done all those, the last thing we probably need to do is like we want to emit an event, right? The transfer event. So we're just simply going to say we're emitting a transfer event, and the transfer event is going to. I think he has. Let's confirm. He has the from. Where is that? Transfer event here, here, yeah. So it has the from, the to, and the value. So our from is simply going to be the owner. Our to is simply going to be recipient, and our value is simply going to be amount. All right. Now I think we have our transfer logic completed. Once again, we check the balances, we update the balances, and finally we emit the event. I think that would be it for our transfer function. So, but before I go, let me check if there are any questions in the chat. All right, just to confirm, can you guys still hear me? I hope I'm not lost yet. Okay. So let's just move on, right? Then we are going to move ahead to implement just here. Here, right, we want to implement the next function, which is transfer from. Now, transfer from, as you can see from the interface, right, is an external function. So in here, we're just going to see the function transfer from, and this takes a reference to the contract state. Okay, and we are going to pass in the sender. Uh, Sender, and what else do we need? The recipient. The recipient, which is also going to be of type contract address. Sorry, this is supposed to be contract address. I keep missing this two up. Okay, this is going to be contract address, and finally we're going to take in the amount, which is going to be a UN 256. Now I think we're going to just do something similar, right? We have the sender, the recipient, and the amounts. What I want us to do now is we're going to delegate the logic for this transfer from function to an internal function or a helper function too. And to do that, we're just simply going to sorry, first of all, we need to get like the address of the caller as the person who has been approved. That's basically the spender, the person approved to carry out this transaction, right? Then after getting that, we're just simply going to do the same thing, right? Make a call to the what we call this now. Um let's call this approve or not approve helper. Okay. No, this is going to basically also make a call because basically it's a transfer function, right? So we can just simply still use the transfer helper. But before then, we want to do something else. So, but before the transfer helper, right, we want to do something else. Now, when the transfer from function is called, right, when this function is called, something happens basically. Like I said earlier, to make this call, a spender needs to be approved by the owner to spend from his balance. So basically, what the spender does now is the spender can now call the transfer from function to transfer a certain amount of our token from the owner to a recipient, to this recipient here. Now we have our owner, which is the sender, and the recipient, but we don't have the spender yet. That's why we got the spender. But we want to do something else. When this happens, right, we want to ensure that we deduct the allowance from the users from the amount of token allowed to the user currently, unless the user would be, let's see, user will automatically have unlimited access to like the owner's wallet, right? So somewhere here, right, we would want to do something like we're going to delegate this to an internal function to spend our allowance. So the spend allowance function basically is going to be responsible for deducting the allowance. That's the storage variable we have here with our storage variables here. So it's going to be responsible for updating the allowance storage variable each time a transfer from function is called. So basically, but it's still, so we want to call the spend allowance helper function first. And the spend allowance helper function basically is going to need the sender. It's going to need the sender, right, which is going to be the owner of the tokens. Then it's going to need the spender, which is going to be the caller. And I think finally it is going to need the amount of tokens. Okay, the sender, the caller. I think we might also need the recipient. Just want to deduct the balance, so we can just ignore that. Then we'll just need the amount. Rather, the amount should be the last thing we will need for this function. We're going to build that now, right? So we don't have the spend allowance function here, but we're going to work on that. But after we've spent the allowance, right, so we've deducted the allowance of the spender, next thing we want to do is to transfer the amount of tokens. So basically the transfer needs the wallet the money is going to go out from, which is going to be like the spender, right? The next step, we are going to need the recipient, the person receiving the money. And finally we're going to need like the amount of tokens we are like sending out. So that's going to be delegated to the transfer helper function, which we've already implemented. All right. Then next up, we want to implement the spend allowance function. The spend allowance function. So we're just going to come here, the helper function, right? And we're going to call this the spend allowance. And this is going to be mutating states, right? So we want it to be like we want it to take a reference to the contract state, right? Then what are the things we need? We need the owner, the spender, the owner, which is the sender, the spender, which is the caller, and the amount. So but in here we're going to just call them the owner, which is of type going to be of type contract address. We're going to call this the owner, the spender, which is also going to be of type contract address. And finally, the amount which we are going to be deducting, which is all going to be a UN 256. Right. Now, within the spend allowance function, the first thing we want to do is like we want to get the current allowance. We want to check if this user who is trying to call the transfer from function has any amount of tokens of our tokens rights approved to him by by the owner of the wallet, right? So we want to see let's current we're going to say let current allowance be equal to self dot, we can do that by allowances the read, right? And in here we're going to pass in a tuple of the owner and the spender. And so when we do this, we're going to get the current allowance that the owner has approved to this spender, right? Now, having done that, the next thing we want to specify is we're going to be specifying like something we're going to call a once mask, and this is going to be, I think, just make sorry. Let's put F in 32 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Then we could just make this is going to be U 128, right? Then what we are going to do now is we want to check that this user does not have unlimited allowance. So we're going to say let's is the allowance is unlimited allowance, right? We want to check that check it right. We want to ensure that the current allowance dot low, because if you come from Cairo 0, right, you know that a unit 128 in a unit 256 in Cairo, right, is basically a combination of two Uint 128 values as the maximum value in Cairo is like the fail 252. So to specify Uint 256, need like two Uint 128, right? Now the low by low basically we refer to the lower part of the Uint 256. Now I want to check that the current allowance dot low right is basically check basically that is not equal to one's mask for all these errors. We want to check that it is not equal to one's mask. And the current allowance is also not equal to one's mask value. Basically, this and here is more like we use that to just um basically turn out to be true if like both ends are true, right? So current allowance. Okay, we said let is unlimited allowance because to current allowance dot low. Okay, let's make this is supposed to be equal to rather not is not equal. So since we're checking for unlimited allowance, so is equal to one's max tax, the maximum value of this user's allowance is like an unlimited allowance, and basically we're going to just use that that edits the allowance for the user, basically deduct the allowance that's been allowed to the user. To do that, basically, we want to make a call to the allowances. We're going to write call to the allowances. And as always, we're going to start with the struct, which is like the owner and the spender. Sorry, the tuple rather, owner and the spender. And the new allowance is going to basically be what is this in there? Okay. The new allowance is basically is going to be the current allowance, right, minus this amount. So the new allowance is going to be the current allowance minus the amount. And having done this, right, we have now successfully deducted the allowance for this user. Now, basically, what happens here now is that's just retreat, right? Is we get the spender, right? The spender is like this the collar guy, and we want to ensure that we deduct the allowance for this user to ensure that he doesn't have like he just doesn't just keep sending out money from this user's account. This is basically to help prevent bugs that can lead to basically draining this user's wallet. So we check using spend allowance. We basically want to deduct the allowance that was approved by the owner to this particular sender, this particular spender. And finally, having done that, we're just simply going to use the transfer helper to transfer a number of tokens from the owner wallet, that's the sender, to the recipient. Right. Let me check if there are any questions just before we proceed. Okay. So someone's asking what does generate streets and generate road do? Okay, so basically what generate traits does is I explained that earlier. Generate traits basically generates a conforming interface for our method. Sorry for that. Sorry about that. It generates a conforming interface for our implementation over here. So, like I said earlier, as you can see here, there are two ways to probably implement this, right? You can decide to implement the interface manually using a treat like we just did here, and then when specifying the implementation, what you would do is implementation of this, right, of the contract states, the of the interface, basically passing in the contract state. But if you don't want to go through the whole stress of generating traits, which we generating an interface, which I believe is not necessary for like a helper function, since a helper function is an internal function and people would not want to make calls to directly to it, right? We just simply use the generate trait to generate a conforming interface for this our implementation. I don't know if that answers your question. Right. Then as for the generate raw, I do not have a lot of idea about that. I'll probably check that out and probably communicate that in whenever we hold another bi-weekly call, but I'm not sure I've seen a generate raw before. Okay, so next up we still have some functions pending. We have the approve function, the increase allowance function, and the decrease allowance function. All right. So for the next function want to implement in here is like the approve function. So the approve function is basically going to take a reference, the contract states. Now we have to run. Yeah, we have less time, and basically we need the spender, the person who's approving, which is going to be contract address, and we need the amount. So the spender is the person who's going to be spending, right? And we need the amount, which is going to be in 256. Okay. Now this approve function, basically, what do we want to do here, right? We want to first of all get the owner. So we're going to say, let's just call it owner instead. Equal to get caller address. Just make things more explicit. And as we've done with others, to keep this cleaner, we're just going to delegate this to like an approve helper. That's what we're going to be calling our internal function. Now, within our approve helper, we want to pass in the owner, the spender, and the amount that we are approving. Okay. So we need to implement this approve helper now. We're just going to come here and in here we're going to call the approve helper. Okay. So the approve helper is also going to mutate states. So we're just going to say contract states in reference to the contract state. And we need the owner, which is going to be contract address. We need the spender, which is going to be contract address. And we need the amount, which is going to be a UINC 256. Right. Now, within the approved helper, what do you think we want to do? I would say let's first of all check that both the owner is not a zero address. Let's check the owner is not a zero address. So we're going to just use the zero. So that owner is no zero. And if it is, we're going to see approve from zero address. Approve from zero address. Okay. And we're just going to do same for like the spender. Want to ensure we're not approving a zero address. Okay. So is zero. And in here we want to say approve approve to zero address as zero. Want to true. Okay, I think that's more specific. All right. Then what do we want to do when we call the approve helper function? So basically, we want to mutate the allowances storage variable, right? Add some new tokens that will be approved for the spender to spend from the owner wallet. Now, if you notice, okay, we could just simply okay, so that we can just come in here, right? And we're going to make a write call to like the allowances storage variable, and this is going to take the owner and the spender, and we want to update it with this new amount, right? So we're going to call this new amount, right? Yeah. So we're approving this spender basically to spend this amount from the owner's wallet. And I think that will be about it. The next thing we probably want to do, right, is to emit the approval. Remember, we have like an approval event we want to emit each time an approval takes place. So we're just going to say self.emit, and in here we want to emit approval. And approval, what do we want to emit in approval? We want to probably emit the owner, the spender, and the value. Okay. So in here, we're going to approving the owner. Since the owner, they are basically same thing, we're just going to do this. Owner, spender, same name, right? Owner, spender. And I think the we have value and amounts. Yep. Right. So then inside here, then we just need to close this, right? And I think that would be it for our proof helper function. So basically, the approve helper just writes the allowance, the number of the amount of tokens that want to be approved by the owner to the spender. All right. Then we have a few more functions to go. Let's run. Let's run. So we have the increase allowance function fix like to add to the current allowance. The added value is going to be like a in 256. Okay. Now this is going to basically going to call we're going to still in here we want to I believe we okay first of all we don't have the owner right, we just have the spender. So let's start with getting the owner using the get call address. Right. Then next up we want to we're going to make a call to the now what we're going to do is we're going to simply do something right. Rather than just passing the amount straight. Remember, once you increase the allowance, not replace the current allowance. So what we're going to do here is we need to first of all get the current allowance using the self allowances, the read. We're just going to simply pass in the owner and the spender. And once we get that, we want to add. So the amount now that will be the new amount is the current allowance of this set of persons, right? Plus the added value. Plus the added value. Yep. And I think that does it for increase allowance function. The decrease again, the reference to the contract states. And as always, we need the spender, which is going to be a contract address, and we need the subtracted value, which is going to be like the subtracted value, which is going to be in 256. Yeah, all cool. Now in here, as always, we're just going to simply do the same thing we did in increase allowance. We're going to get the call address. We're going to get the call address, and we're going to call the approve helper. And in here, we want to pass in the owner, the spender, and as always, we want to get the previous allowance of the owner to the spender, and we're simply not there. We're simply going to subtract the subtracted value. Yep, and I think that does it for our decrease allowance. So let's close this so we'll have more screen estates. And as you can see here, we no longer get an error on this, right? Because we've implemented all the interface we need, right? We've implemented all the interface we need. And now let's see if this compiles, right? So we're just going to open a new terminal. And I'm going to run scar build, right? Let's see if we run into errors. Right, so there are no errors. And as always, if you head in here, okay, everything is compiled into one. Let's forget about that for now. All right, so let me see if there are any questions because we're running out of time. It's no questions. Okay. So the next thing we're going to be implementing, we have less than 30 minutes to go, right? So we are going to run in this next one. I guess we're just going to let's go for something more a bit difficult, right? Let's not in here. Let's do this in here. So let's implement an account basically with a multi-call capability. So let's just for simplicity's sake, let's just call this mini multi-call. Okay. And yeah, so in here we want to create a new file. Let's call this file, let's call this multi-call dot Cairo. And in here we want to still create a, we want to do mean multi-call dot Cairo. And I'm just going to specify the multi-call here. I'm going to specify the multi-call here as the file, this file here. And in here we're just going to simply do this. We're going to do this. Right. Sorry, this is mean multi-call. Right, so we're just going to head to the multi-call contracts and we're going to work on this. Right, so for the multi-call contracts, right, as always, if you know, okay, probably if you wrote the old Cairo, right, the old Cairo one, probably for like for an account contract, you'll probably have used the account contracts attributes. But I think with the new syntax, you don't need to do that. Everything just is the stacklet contract attributes, right? And we're just going to come here and we're going to, let's call this account contracts. Account contracts. And in here, we want to import some certain things we're going to be using from core library. And some of these things will be, I'm sure we're going to use the get call address. We're going to track 6 call. We're going to need the get block timestamp. I can't think of anything else for now. Okay. I think we are also going to need like box treats, and there's also going to be a need for array treats. We're going to need the array treats. Let's import this, like the span treats. We're going to need this. All right. So because of time, we're going to run in this, right? So we're going to start with declaring our storage variable. And this is going to be like a storage struct, right? And then in here, the only thing we'll probably want to store here is our public key. This is an account, right? And the public key is going to be a field 252. Okay. There are no events, so we're just going to head over to our constructor. Let's head over to our constructor. Okay, so the constructor basically is going to need a reference to the contract state. Okay, and what else are we going to need for the constructor, right? The public key. We're going to need the public key. Public key we want to initialize for this account on deployment. Okay, that's cool. Then within the constructor, we're just simply going to just do this. We're going to initialize the public key to write to it. And yeah, the public key. Okay. I don't think there's anything I want to do within the constructor. Then I'm going to just declare this outside. Okay, let's just use external v0. And in here we'll probably want to just declare the validate deploy. Right, so because of time, I'm probably not going to be explaining what these functions do, but if you check, I think in the Stacknet book, right, there's a dedicated chapter on accounts which you could explore to check out all these functions. Or if you check the mini Stacknet repo, basically, I made sure to add comments, certain comments that explained most of what this function does, right? So we just have 20 minutes to go, right? So the next thing this is going to, let's just give this a snapshot rather. I don't think this will mutate in any states, right? And the validate deploy is going to need okay, let's pass in the contract address. Let's pass in the contract address sold, which is going to be a type of L252. We're going to need, that's actually the first thing we need, is the class hash. Let's get that. So we need the class hash. The contract address, so to probably need the entry point selector. Need the entry point selector is going to be field 252. And any other thing we'll need just pass in the public. Okay, I think we'll need the public key. Actually need that. So we just want this to return the field 252. And in here, we're just going to do something simple. We're going to pass the logic to this validate transaction internal function. Now, let's implement that validate internal function before we go ahead. And for this particular, since our internal function, I would just generate the trade automatically. And it's going to be implementation. Let's just call this account helper implementation of account helper treats. And we want to implement the validate transaction function. So it's called the validate transaction function. We're just going to pass it snapshots too, right? And it is meant to return a field 252. What do we want to do inside here now? All right. I think the first thing we probably
All right, so we lost Darlington again. Let's just give him a few seconds to try to come back. And yeah, otherwise we'll just call it a day. So anyway, for those who will be in HCC next week, Julien, one of Argent's co-founders, is gonna give a talk, which is called "The Invisible Wallet: How to Make Crypto Magic." It's gonna be on main stage, and just checking the dates, it's gonna be on July 20th from 11:15 to 11:40. So don't hesitate to come and say hi. Let's just wait a bit longer. Yeah, and indeed, I also get the message that there is also going to be a panel on July 18, also at HCC, with Yoav from the Ethereum Foundation and again Julien from Argent. The topic will be account abstraction versus EOAs, so externally owned accounts. So basically, comparing the older generations EOAs like MetaMask and newer account abstraction accounts, smart accounts such as Argent. All right, so maybe we have Darlington back.
Yeah, I'm back. Can you hear me now?
Yes, we can hear you, Darlington.
I'm really sorry about that. I don't know. My network went off. Okay.
No
So
worries. Yeah, so maybe just before going back to your codes, I see there is a question also from John, who's been very active in the chat today, who was basically asking if he can deploy one of these contracts himself.
Yeah, basically you could do that using Stackly. Okay, I think we might do that. We might just do a brief deployment using Stackly before we end the call, right? But maybe I'll just try to run through the multi-call contracts with a brief deployment, and then we might just call it a day. Oh, right. So, but you guys can see my screen now, right? Okay. All right, sorry about that. So the validate transaction function, the first thing you want to probably get right is the transaction info. Not from here. So I have the get transaction info imported. It's just I don't think we have init for the block timestamp. Okay. Now we need get transaction info. Yeah, we're just going to unbox this since this will return a box type. Yep. And we will, what else we want to check, right? Let's try to check the signature length. So let's confirm that transaction info dot signature length, right? It's like we want to assert that this is um length is 2, else we want to just draw an error that says invalid signature length. Invalid signature length. Now we see an error here. It says signature. Oh, sorry. Transaction info dot signature. You know what? Let's just get this signature to make things cleaner. Let's get this in here. Let's say transaction info dot signature. And in here, what we're just going to do is we're going to say signature dot length. I think, yeah. So basically, length is a method contained within the array treat and span treat that returns the length of an array. Now, next thing we want to do is we want to check our signature. I want to check that the signature is valid. To do that, we'll probably have to import from Ecta. We'll need to import the check Ecta signature. Uh, Sorry, can you see my screen? It's still frozen out. Okay, let me confirm it. Right, so try to fix this. Okay, check Ecta signature. Sorry. Check Excel signature. We want to pass in, or need to get, I think, the message hash. And message hash, we could just pass in the transaction hash in there. And the next you'll probably want is the public key. And for the public key, you probably need to get that. Let's just get that stored somewhere. Let's see. Let public. Let's public key be equal to self dot public key the read. Let's just read that and store it somewhere. So we could just come here and in the public key we could just paste this. Yep. And okay, so finally we would probably need this R component of the signature, which could be just make that the the signature of this element of the array. Then signature this component will basically be Basically, the asterisk sign I'm using is to snap this, right? Because this is like a snapshot. So I'm just basically snapping it. Okay, so I think my screen keeps freezing. That's why I'm trying to like take it off and bring it on again. Network. Okay. Right. Let me check. Is it still freezing? Okay. Nope. All right. Then after the check extra signature, right, we want to return an error invalid signature. Okay. And just close it. But if it's valid, we could just simply within the value 252 that we'll probably need to import from here. We could just come here and import the validated, right? Okay, so we just have 9 minutes, so I'm just going to rush through the remaining implementation. So because of time, I'm going to use the generate trait in this case. I would have loved us to just okay, let's just 0. Okay, and in here we are going to let's generate the traits automatically by ourselves, and let's just call this implementation account contract implementation of account contract traits. Okay, so yep. So one more thing I just realized is we would need the call struct. Rather than specify it manually, we could just import that from I think account call. We could get the call struct from there. That's possible. All right. So within the account contract implementation, we want to start with the let's just start with the validate declare. Now the validate declare, we want to pass in let's just pass in snapshot also of the contract state. Yep, and we're going to pass in the class hash. Class hash, which is going to be field 252, and we will just return the field 252. So this basically is going to just make a call to the right self to validate transaction. Yep, we're just going to make a call to that and return whatever we get. Now, we're going to need the validate functions, validate transactions. This is going to, we could just pass a reference instead here. Reference, and we will probably want to just pass in the calls as because we are assuming this is going to be multi-call, right? And it's going to be an array of call. Yep. And we want to return if it's 252. So we're just simply going to, in this case, just call the validate transaction. Okay. Then the last function we would probably need to implement is the execute function. Now the execute function is going to definitely take in a reference. It's just going to be mutating state. Okay, and let's just pass in the calls. It's going to be an array. I think this is not. You could just an array of call. Yep. But this time around, we want to return an array of span. Yep, of L252. Okay. And in here, what we're going to do basically is the first thing we want to do is we want to check that the caller is zero address. So we're just simply going to say let's caller equal to get caller address, and we're going to go forward to check assert that the caller is a zero address, else we assume it's an invalid caller. Okay. Yep. So we're going to come here and just import the variable in order to be able to use that method. And after checking that, right, I don't think there's much to do. We'll just we need to check the transaction version. So we're just going to say we're going to start with let's transaction info be equal to get transaction info, right? And we're going to get that, and we're going to unbox that. Okay. Then finally, we're going to assert that the transaction info, the version is not. We want to check that it is not equal to 0. Else we throw an error that says invalid transaction version. Okay. Yep. So having done that, we're just simply going to pass the execute multi-call to an internal function. I'm going to call this internal function executes multi-call, and we're going to pass in our calls. We're going to span it. So now we're going to need to implement this execute multi-call function. So I'm just going to come here, right, and we're going to do this. This is going to take a reference to the contract state. Yep, and it's going to take this time around the call is going to let's just do this. Call is going to be like a span because we passed it in as a span, right? So span of health 252, and we want to return an array of span of health 252. All right. So within this execute multi-call, we're just going to initialize the result, which is going to be of our return type, because that's what we're going to return after we're done with our multi-call. And we're just going to be an array basically. So we're going to be initializing an array. Okay. Then let's just do this to make the calls mutable, as we're going to need to loop through it. Let me check that I'm not lost. Okay, so we're out of time already. All right, so what we need to do here is we're going to run a loop, right? And we're going to be matching calls dot like pop front. We're going to be popping each call, and we want to check if it has a call in it. If it does have a call in it, right, we're going to do something interesting. We're going to see the result. Okay, if he has a call in it, we're going to do something. We're going to say match call contract syscall, and we're going to pass the call dot to the call dot selector, and the call dot call data dot span, right? And if he returns a result, it's okay, right? We want to do something. We want to simply just append. Now the result is going to have something here. So it's going to have a return data. So we want to just append that return data to like the result. And but if it returns an error, right? We're going to have a reverse reason. What we simply want to do is just panic. It fell 252. And we're going to panic and say multi-call field. That's what we're going to simply do. Right. And that would be for this. And then, okay, sorry, that's not there. that will be for this, right? Uh, and then for the non option, what do we want to do? We're just simply going to break our loop. Just simply going to break our loop. All right. Then let's do this. We have an error. It says call type at call failed 252 as no member of where am I missing? Let me use calls equals calls. Right. Having error somewhere. Type at call failed 252 as no members. Match calls the pop runs. This. Um hope that doesn't solve. Yep, I'm running into errors with something. Let me go back to okay. I think it should be from here. So in here we said unexpected argument type, expected core array span, core paper and queries. Okay. Mm, oh, sorry. Hmm. Let's see. This is a span. It's basically we basically do not need this, right? Then this is that's wrong. We want to return array span failed 252. We self execute multi calls. Query span code field. Cool. Do we have to generate traits here? Right, guys. I'm running to an error with this, but we are already out of time, and I really wanted to show us how to deploy a contract. I'll try to fix this error, and like I said earlier, I'm going to try to be updating the MinStacknet repo basically to the new syntax. So I'll just fix the error and I'll move stuff into there. So this is going to return data basically. We return data. Oh, we have little error which I'm not sure from where, which I'll probably try to fix later. Yep. So we are out of time. Now we have the last question. We have one more question. We have one more question. Why is the caller set to zero address? Okay, for the account contracts, basically, we want to ensure that the originating the where the call is originating from, right, is not invalid. Like it's not a normal address; it's a zero address. Else, we can assume that maybe someone is trying to like call the execute function, which is not supposed to be possible. And I think that would lead to like a reentrancy attack. So can we deploy the previous ones? We are already out of time, but to deploy a contract is not very difficult. To do that, we can use a tool called Stackly. We can use the Stackly tool, which was built by Jonathan from Zikilend. I guess we'll probably have to leave that till our next call, which is probably going to be 28. In the next call, we're going to try to build a few more contracts and deploy every single contract. We are already out of time. Right. Thank you so much for joining the call. Thank you, everyone. I apologize for the slight issues with my network. Promise next call is going to be better. And yeah, if you have any more questions, you could reach out to me on Twitter or on Telegram. I would always be excited to help you out. And just to re-emphasize, right, like this is just the beginning of our bi-weekly workshops. So we're going to still be having another, like I said, by 28th July. So do endeavor to tune in. And yeah, I think we'll call it a day here. Thank you, everyone.